Yesterday's concept was if we took 2 points, one had an x coordinate and one had an actual value, a, then you would have a y coordinate with x and a y coordinate with a. And the idea was yesterday is if x got closer and closer to a, which was this limit formula at the bottom, then the secant line would get closer and closer to the tangent line. And so as x gets closer to a, this point B gets closer and closer to the point A. But the problem is, on the bottom, you're dividing by 0. So this is a typical limit problem where you're dividing by 0. But if we can evaluate this limit, then that limit would become exactly the slope of our tangent line. And we did an example with a parabola, and we looked at the point 2, 1. And as we got closer and closer to 2, so in this formula, whatever the a value is the x coordinate where you want to find it. So we want to find the slope at 2, 1. Then your a value is 2. And you're finding the limit as x gets close to 2. And something really nice happens here. The 1 cancels out. We could factor. Things simplify. And the slope works out. And the crazy thing about this limit is, you're sometimes as a student you go, oh, did the teacher pick a nice point? Did they pick 2, 1 on purpose because it worked out? The crazy thing about this limit is no matter where I would pick a point on that parabola, it would always work out, and it would always factor, and it would always solve, which is kind of interesting. So we did a couple of examples with this formula that says x is getting closer to a. Now, today, we are doing the same thing, but using a different idea. The different idea this time is instead of taking a point x and a point a, we instead introduce this horizontal distance as h. H for horizontal distance, not h for height. Oh, my goodness. Totally throws everything you've learned in the past. Actually, h for horizontal distance, I just made up right now. I have no idea why they decided on the letter H. But we'll go with horizontal distance. It has a little bit of logic. So instead of having a point x and a point A, we have a point A. We call this distance h. Does it make sense that this other point then is A plus h? So we're going to do exactly the same process with a little different perspective. Instead of saying that x is going towards A, we now say that we want h to go towards 0. And if h gets closer and closer to 0, in other words, you keep making this distance smaller, as you make that distance smaller, B would have to get closer to A, and we have exactly the same thing, but we're writing it as a different perspective. So this becomes our slope formula number 2. That now your horizontal distance is h, and your vertical distance would be whatever these y coordinates would be, which is f of a plus h minus f of a. And so we get our second formula for slope, which now says instead of the limit as x goes to a, it's just the limit as h goes to 0 of f of a plus h minus f of a. And the a value is going to be that x coordinate at the specific point you want to find. So in reality, these two formulas are exactly the same. They're just written a little bit differently, depending on what you chose as your variable and what you're making, what thing you're saying is approaching. Yeah, I couldn't find a good words to say that, so I just stopped. So here's our new formula. We've got the limit as h is going to 0. H is on the bottom, so we're still dividing by 0, causing a problem. And we have the y-coordinate of 1 minus the y-coordinate of the other. In this situation, so our slope is equal to this, our slope of our tangent. Now, our value, we're finding it at point 3, 5, so this will be what we plug in for a. F of 3 plus h, we're going to have to figure that out. But minus f of 3, you already know is 5. Because we have the point. You could plug it back in. We could write f of 3, actually plug it into the formula, 3 squared minus 4, and calculate it to be 5. But they've already given us the point 3, 5. So this part is easy. All divided by h. And so what we need to do is we need to plug in this 3 plus h in for x in our formula. Because that's how functions work, right? Technically, our function here is f of x is x squared minus 4. And you know how to figure out f of 3. You would plug in 3 or 4, and you would get 5. So it makes sense that we have 5 here. Even though the point was given, we could steal it from there. But you know how functions work. Whatever you plug into the function, if I said, what's f of 1? You would plug in 1 for x and do 1 squared minus 4, right? If I said, what's f of 10? You'd be like, okay, I'll plug in 10. 10 squared minus 4, right? And you can plug in anything for x. If I said, what's f of Alice? It would be Alice squared minus 4. And even though it's weird, it's actually the same process. But it's that weird process that's important, because as soon as you see more than one thing in f, people all of a sudden go, I can't do this. You can't. Because all of, f of 3 plus h means the same thing as f of Alice. F of Alice is Alice squared minus 4. F of 3 plus h will be 3 plus h squared minus 4. I'll put that in big square brackets. We still have the minus 5 here. We still have the h on the bottom. Does that make sense? Whatever you plug into f, this function says whatever we plug in gets squared, and then you minus 4. But we get so used to just plugging in single numbers and being like, I'm good with that. And as soon as you're like, let's plug in a little bit more, you're like, whoa, I am now not okay. And it's actually the same idea. That's the big thing in mathematics, that we're looking for patterns as what's the big idea of what's happening? Then we can do it with anything, right? And this course will push you to see things that you maybe didn't see before. Like factoring a difference of squares where one of the numbers isn't a perfect square. Well, let's go to square roots. It's the same idea, then it works. Okay, so now when we expand this, three plus h squared, careful, this is not 9 plus h squared. You do have to do 3 plus h times 3 plus h, multiply it all out, do all the arrows, and you would get 9 plus 6h plus h squared, right? I'll do that off to the side. This is what 3 plus h squared means, and you would have all of this happening. lots of times we don't think about what it means and we just say, oh, I'll just square 9 and I'll just square h. And then you're going to run into all sorts of problems after that. So I still have this. That would be what's in that square brackets. Minus the 5 still all divided by h. We have to keep writing this limit as h goes to 0 until we get to a point. Oh, I forgot the minus 4. Yes, thank you for noticing. That minus 4 would still be there. That's where the bracket would close. Minus 5. So we still have to have that h there. I hope you can see that 9 minus 4 minus 5 will be 0. And now on the top, you can factor out an h, leaving you 6 plus h on the top, h on the bottom. And this is our goal. Just like every limit, we want that non-permissible value to cancel out. Once that non-permissible value cancels out, then you can actually apply the limit. You can plug in 0 for h, and we find out, right, what does this mean? The slope of the tangent at 3, 5 is 6. That is what we've discovered. Yes?
Do we always need to write a statement like that?
At this point, no, because the question, I'm going to say no. The reason I am at this point is because this is really getting at the big idea of what we're doing. I want us to always be aware that what we're finding is the slope of a tangent. That's our whole first unit on derivatives, is about finding slopes of tangents. And these two formulas that we have so far find us specific slopes at specific points. What we're going to be doing on Friday is figuring out how we can do a more general form so you can get a formula for every slope at every point. But right now, we're looking at specific slopes at specific points. So I'm writing the statement because the idea is very important. Now, I'm reading this question. One of the things that a person should always do when they're doing a math question, especially as you get into higher math, where there's a lot of work that we did. We did all of this work to find the slope of the tangent. And sometimes it's good that I wrote a statement, right? The slope of the tangent at 3, 5 is 6, because when I reread the question, I can ask myself, did I answer it completely or correct? And I read this question, use this new formula to find the equation of the tangent line. I just found the slope of the tangent line. And the question is asking for the equation of the tangent line. So rereading the question tells me I'm not quite done. And now we get to review grade 10. Do you remember how to find the equation of a line? Do you remember how to do that from grade 10? You need two things. You need, one, the slope. Good thing, we've got that. We know the slope is 6. And the second thing you need to find an equation of a line is a point. Well, that's good. You have a point, 3, 5. So the two things that you need to find an equation of a line are slope and a point. We have those two things. And now there was two methods you learned in grade 10, and I will show you both of them and see which one you remember better. Method 1 was using this formula. Do you remember this formula for a line? Y equals mx plus b. If you remember that formula, what we have right now is we have m, so you would be able to plug in 6 for m, and you have a point, so you know that when x is 3, y is 5. The only thing you don't know is b, the y-intercept. But if you plug in your slope and you plug in your point, could you solve for b? Yes. I just have to subtract 18 on both sides. I would figure out that b is negative 13. And now I could, write the equation. I know the slope is 6. I know the b value is minus 13. Method 2, do you remember this equation of the line formula? This is called the point-slope formula. And usually I get exactly that reaction. How many of you remember y equals mx plus b better than y minus y1 equals mx minus x1? Okay. This is typical, right? Because it's easier to remember. It's like the most common line formula. This one is called the point-slope formula. And people like this one because it has a place for your point and a place for your slope. So you would plug in y minus the y coordinate is 5, slope is 6, the x coordinate was 3. And then if you want it to look like this, you just need to rearrange this to be y minus 5 equals 6x minus 18, add 5 to both sides. And in the same amount of work, I get the same answer. Technically, your point-slope formula is just can you see that if I would divide both sides of the point-slope formula by x minus x1 to get m by itself, all the point-slope formula is your slope formula rearranged with only plugging in one point instead of 2 points. So sometimes that helps people remember. Okay? But I agree. I remember y equals mx plus b way better than the point-slope formula. Some teachers like the point-slope formula because it allows you to plug in your point and your slope, and then you've already got your equation. You're just rearranging. Some teachers like y equals mx plus b because students remember it better. But you have to solve for b and then rewrite the equation. And sometimes students solve for b but never actually write the equation after solving for b. They're like, oh, I solved for something. I should stop. Which is pretty typical as well. So they're both there. And now if I reread the question, now we've answered this completely. So let's look at the next one. It's the same idea. It says, use this new formula. So I'll rewrite the formula so we have it again. That our slope of our tangent is limit as h goes to 0 of f of a plus h minus f of a over h. This time, we're finding at the point 6, 3. So our a value would be 6. We're finding the limit as h goes to 0 of f of 6 plus h minus f of 6, which is given to us already to be 3 over h. Right? Same thing. You've got your equation. You can think of this as f of x equals x plus 3. You know that f of 1 would plug in 1 for x. F of 10, plug in 10 for x. F of Roham, plug in square root of Roham plus 3. I might get a little messy. I don't know. But you can plug in 6 plus h. It would be square root, where the x is, you now would have 6 plus h plus 3 minus 3 over h. And we have a problem because we're dividing by 0. So we have to use our limit skills. I hope in this one you can see that this is the place with the square root. You'd multiply by the conjugate, use your skill with difference of squares. Inside here, this would be 9 plus h, and then I would go by plus 3, and on the bottom, same thing. Because I want to multiply this by something that makes a difference of squares, so my square root goes away. If I do that, on the top would become 9 plus h minus 9 over h, and on the bottom, I will leave it factored out because I want that h to cancel out. I hope you can see that the 9 would be 0, and now h divided by h will simplify. They simplify, that means we still have a 1 on top. But now the whole thing is simplified to this. And this is something we can now plug in 0 and evaluate. Square root of 9 is 3. We're going to get 1/6. The question asked us to find the equation. We need two things. We need the slope, which we have. We need a point, which was given to us as 3 comma, no, not 3, 6 comma 3. I'll just do one of the forms this time. So if I use y equals mx plus b, I know that when y is 3, my slope is 1/6, my x value is 6. 1/6 times 6 is 1. Move that over to the other side, you would get b is 2. So your equation is 1/6 x plus 2.